Today we're talking about rewriting equations and formulas, but the actual math term is called literal equations. Now call them literal equations because when you talk about the word literal, literal, literacy is reading, and literal equations reading is words and letters. So today we're going to deal with equations that have a lot of letters, in other words, a lot of variables, and not necessarily a lot of numbers. The reason we want to review before we talk about this particular topic is because when we talk about solving both literal equations and quote unquote normal equations, which contain one variable, the process of solving is the same. We isolate the term that contains our variable, and then we undo multiplication or division. In other words, we reverse PEMDAS, or we do SADMAP. We undo addition, subtraction, undo division, multiplication, then undo exponents and undo parentheses. Now it's tricky, right? Because sometimes we're not ready to start undoing because we have to combine like terms, and then we start SADMAP. Those rules still apply. But let's just talk about undoing in the process that we know. Now, what I said to you is we have to isolate, and the word isolate, as you may know, means to not isolate. Isolate means to get the thing by itself. So if you're isolated in a classroom, you're sitting off by yourself while all your friends are all hanging out together. You've been isolated. Isolate means to get by itself. So if you think about terms, terms are separated by plus signs, minus signs, and equal signs. Really, our first step is to get the term that contains the variable by itself. And that's really what we do when we solve an equation like number 2. We get this term by itself by minus 10 minus 10. That's undoing addition subtraction. Negative 3p equals 30. In this example, number 1, this term that contains the variable is already isolated. So I don't have to undo by addition subtraction. I'm ready to undo the multiplication and division. In this case, since m is holding on to 4 by multiplication, I divide, division property of equality, m is equal to negative 5. Here, in this example, since p is being held on to this value, negative 3 by multiplication, again, I divide by negative 3, divide by negative 3. I've now gotten p entirely by itself, negative 10. Now, remember, it's not just p, it's really 1p. It's 1 times p, but we kind of ignore that value in the front because we're looking for just 1p. We're isolating just the variable. So we isolate the term that contains our variable, and we isolate the variable itself by undoing addition subtraction. Skipping ahead, hypothetically, even if we had parentheses, we still distribute whoosh whoosh, or you could divide by 4 since it's on the outside and just have 2p minus 3 equals 12 divided by 4, which is 3. Now, 3 terms, all of which are separated, 2p, negative 3, and positive 3. So only one of these terms contains the variable that I'm looking for. And that term, of course, is the 2p. So I want to get the 2p by itself. By getting rid of the negative 3, I add 3 to both sides. So now I have 2p equals 3 plus 3 is 6. Now that this term has been isolated or gotten by itself, I undo multiplication division, p equals 3. I haven't shown you anything new except maybe this division thing. But you should understand the whole process of solving, I just use some different phrases, right? Instead of saying I add 12, undo addition, subtraction, what I'm saying is I'm isolating 8p. Really the same thing, right? Divide by 8, we get p is equal to 3. So we solve it the same way. Here's another example, question 8. Solve for y. In other words, make it y equals. That's what solving for y is, getting just the y by itself. There are 1, 2, 3 terms. I want to get the term that contains my y by itself. So I will subtract the stuff that's not y. I'll have 2y equals. Now 10 minus 4, I know what that is, but just to play it out, let me do 10 minus 4. I have 2y equals 10 minus 4. If I divide that by 2, every term gets divided by 2. So there's 1, 2, 3 terms, all 3 of which get divided by 2. I have 10 divided by 2, which is 5, minus 4 divided by 2, which is 2, and 5 minus 2 is 3. Would have been a lot easier if right away, instead of doing this whole thing, I just decided to actually do 10 minus 4, and I had 2y equals 10 minus 4 is 6. And we divide by 2, y is equal to 3. However, sometimes we can't do that. In this case, we could do 10 minus 4. But if you have a question like this, where there are still 3 terms, but if you notice the 4 is now the letter C, the variable C, I still follow the same process of undoing. There's 1, 2, 3 terms. I want to isolate the term that contains my variable. This term contains a variable, but it does not contain quote unquote my variable, which is y. That'll be that one. So what I need to do is get this term by itself, minus c. I'll have 2y equals 10 minus c. Now, a couple things I want to talk about at this step. The first thing I want to mention is I can't subtract this to get like 6, like I could there. So I have to leave them as separate terms. But the other thing I want to say, and you're going to hear me say this a lot, is send the constant to the end. So I rearrange the order. 2y equals negative c plus 10. Notice what I did. The 10 is still positive because it was positive here. It was not negative. And the c is negative because the c was negative there. So yes, you can switch spots, but you can't just switch it however you want. Like you cannot make this c minus 10 because this would imply that 10 is negative, which it isn't. So if you switch them and send the 10 to the end, 10 is positive, c is negative. All right. At this stage, I still have 2y equals negative c plus 10. Every term gets divided by 2. Y equals negative c over 2 plus 5. Of course, negative c over 2 is negative 1c. So if you see me write negative 1/2 c plus 5, either one of these would be acceptable. This one is better because I put that 1 out front, which was already there. So just negative c, I made it negative 1c. And then I brought the negative 1/2 out in front as a coefficient. Either one's acceptable, but again, technically the one on the bottom is better. Therefore, the thing we need to understand is that it is possible to solve for an unknown or a variable, in this case, y. In other words, isolate it, get it by itself. Even if the other terms are not numbers, if they're variables, we can still do this process of solving by undoing using send. This is a very good example of the types of questions you're going to see quite a bit when we rewrite equations, when we do literal equations. Now, the instructions are a little confusing, though, so let's go over that. It says to rewrite so that y is a function of x. Now, if you look, there's only 2 variables, y and x. The question is, if I rewrite it so y is a function of x, am I trying to make it y equals or am I trying to make it x equals? So as you think about that for a second, I will reread the sentence. Rewrite the equation so that y is a function of x. And the key here is that y is. The word is means equals. So y is means y equals. So we're trying to make it y equals. In other words, solve for y. There are 3 terms. We need to isolate the term that contains my variable, which is 10y. Subtract 4x, subtract 4x. I have 10y on the left, and I certainly could say 12 minus 4x, but send the constant to the end, send the constant to the end, send the constant to the end. So in this situation, 12 minus 4x is really a negative 4x plus 12. And everything gets divided by 10. Y is equal to, Negative 4/10 simplifies to negative 2/5. And I'll move it out front, make it a coefficient. And 12/10, I wish it was a nicer number, but it's not. So it's just going to remain as plus 6/5. Here's another example that's going to be a little bit nicer. I'll start you off. In this situation, there are three terms, negative 2x, negative 6y, and 8. Remember, that's not really a subtraction sign, it's a negative 6x. So I want to get the negative 6y, which is the term that contains my variable by itself. I'll add 2x, add 2x. I'll have negative 6y on this spot. Just so you know, what I often see as a common mistake is students say, oh, 8 plus 2x. That's 10x. I'm not sure how all of a sudden, when we combine things that are not like terms, all of a sudden, this thing becomes something that we can combine. They're not like terms. It's not 10x. It's just 2x plus 8. So I kind of lied. It actually doesn't work out super nicely. Give you a second. You should finish this. So you can pause the video if you'd like. Coming back, if I finish this problem off, everything gets divided by negative 6. Y equals 2 over negative 6 is negative 1/3. X minus, because a positive divided by negative is a negative, so minus 4/3. You could leave it as 8 over 6, but you can't leave it as a plus with a negative in the bottom. That makes no sense. Make it a negative at least. I like the negative on the coefficient on front, but you technically, I guess, could put 1x over, or negative 1x over 3. This is better. This one you should do on your own. We will go over that next class, but you can go ahead and practice that one on your own, and we'll come back to it. Number 4 says solve for m. Makes it very easy instructions. This is a super easy one. Isolate the term that contains my variable. This one contains my variable, so I divide by 4, and I divide by 4, and I'm done. M equals 3x over 4, but just as a reminder, and if you weren't getting this before, maybe this will help. If the variable is on top, it can move to the side. It's equivalent. So m is really equal to 3/4 x on the side. So a little bit better, but if you left it as this, that would also be acceptable. Here's another one, number 5. Number 5 is a little bit trickier, right? Because m, while this is one giant term with a whole bunch of multiplication, it's multiplied by two things, and that's kind of weird. So I have to undo both of those things. Now I know to get rid of the 3, I divide by 3. And how do I get rid of the multiply by p? Well, the same thing. Even though they're not in front, I could still cancel that out and cancel that out, and I divide by 3p on that side. On the left side, I have m. Now I told you to finish this on your own, but there's really not a whole lot to finish. It's just 8 over 3p. And that is it. If you decided to move the p to the side, this is not one where the p can move to the side. Once again, if a variable is in the top, it can move to the side. But if a variable is in the bottom, it has to stay in the bottom. This is 8 over 3p. Do not move the 8 or the 3 from the top to the side. It stays in the denominator. This one, again, you should try on your own. Note that it's very similar to number 5. As a general rule, my suggestion would be to get rid of the fraction right away. And now we know how to get rid of the fraction by multiplying by the reciprocal, which is 2 over 1. 2 over 1, those cancel, and the 1s cancel. So 2 over 1 times a, again, 2 over 1 times a, that's just 2 times a. So the left side is 2a equals b times h. No more fractions, which is nice. So we're solving for h. Divide that side by b, divide that side by b. H is equal to 2a all over b. If you want to move the a to the side, you can, but it's already kind of weird, so we could just. Number 2, same idea. We have a fraction, which we don't like, so we'll multiply by the reciprocal times 4/3. Do the same thing to this side, times 4/3. Cancel, 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 cancel. And I have 4a all over 3 equals b times h. This one gets a little more complicated because we have fractions. I did ask for you to finish it, so you can go ahead and try to see what you would get. Pause the video and see what you got. What I imagine you would have done is, since you're solving for h, you divide by b and divide by b, which is the correct move. But then you got this weird thing where it says h is equal to a fraction 4a all over 3 on top of another fraction, like a fraction in the numerator. We actually can't leave it like that. So another way to think of it is, this is 4a over 3 divided by b. So I'm going to write this a different way. 4a over 3 divided by b. Which, if you think about division, we don't do division. We do keep, change to multiplication, from division to multiplication, and then flip. Flip b over 1 to 1 over b. That's 4a times 1, which is 4a, and then 3 times b, which is 3b. The answer is 4a over 3b. H equals 4a over 3b. There's a quick way to do it. I'm not going to show you that. We'll get more practice with this next class. Here's a word problem. There's an actual formula. Celsius equals 5/9 times the entire quantity, 32 less than F. Rewrite so that F is a function of C. So obviously it's not solving for C because it's already solved for C, but there's another hint, F is. Looking at this, first thing we're going to want to do is multiply by 9/5 because this entire thing is held together. We've practiced getting rid of that fraction before, times 9/5. This is now 9/5 times C, 9/5 times C, is equal to F minus 32. No need for the parentheses anymore because all we have is F minus 32. Add 32 to both sides. That cancels, and F is equal to 9/5 C plus 32. We'll use the same formula to move down here because we know that C was 6. So no need to start here. I mean, you could plug 6 into C there and then solve for F again, but I've already solved for F. F has already been isolated. The hard work has been done. So what I'm going to do is plug in 9/5 times C is now 6 plus 32 equals F. You follow your order of operations, you do all your calculations, you'll get F is equal to 42 and 8/10. So my answer is 42.8 degrees Fahrenheit. We'll do more word problems next class as well.